All right, we are on 7.03, and today's notes are going to be talking about reference angles and also radian measure. All right, so first we're going to start by talking about graphing angles in standard position. So standard position means a few things that we need to talk about. Standard position. Okay, so first of all, in order to be in standard position, your vertex has to be at the origin. It's always going to be at the origin. And draw a little picture over here. So your vertex would be at the origin. Your initial side of the angle is always going to be the positive side of the x-axis. Okay, so right here, these are negative numbers to the left, positive to the right. So this right here is your initial side. That's your vertex. And your terminal side will be wherever the angle ends. So just the other side of your angle. So if our angle terminates here, let's say this would be your terminal side. So that means it terminates in quadrant 1. Remember, this is quadrant 1, 2, 3, 4. It makes like a C when you number your quadrants. One other thing to take note of here is that when you are looking at this angle, it's always going to be going counterclockwise. So if the angle is positive, you're going up counterclockwise. And if the angle is negative, you're going to be going down clockwise. So going this direction downwards means it's going to be a negative angle because you're going clockwise. All right, so those are really important things to remember. Now we're going to take a minute and sketch some of these. So sketch each of the angles in standard position. And let's state what quadrant it terminates in. The angle terminates in. Okay, number 1 is 45 degrees. All right, so to sketch this in standard position, we're going to draw a set of axes. I'm going to switch colors so you can see. Our vertex is always at the origin. Our initial side is always along the positive x-axis. And the 45 degrees, so to figure out what quadrant it's going to be in, we know from here to here is 90 degrees. If I go from here, this initial side, all the way to this side, we've gone a full straight line or 180 degrees. If I start at the initial side and go all the way down here, that's 270 degrees, and then a full circle is 360. So now if I want to find the, here, if I want to find where 45 degrees is, I look at these angles as to judge what quadrant it should be in. So 45 is half of 90, so that means we're going to be halfway through this quadrant. Also draw a little arrow indicating what direction your angle is going towards, so counterclockwise, 45 degrees, that would be in standard position. Let's try another one. So let's do, go down here, negative 120 degrees. So now we have a negative angle. So again, we're going to start by drawing our set of axes. Let's label 90, 180. Actually, you know what? We're going to go the other direction. So I'm not going to put those labels on quite yet. And because it's negative, we're going to start by going downwards. So we're still going to have the vertex at the origin. Initial side's going to be your positive x-axis. And this time, instead of going up 90, we're going to go down. We're going to start by going clockwise. So this is actually going to be negative 90. And this would be negative 180 and negative 270, negative 360. So a negative on an angle only tells you the direction of the angle. You still have the physical angle is open 120 degrees. It's just going in the negative direction. So meaning it's just starting by going down. That's all the negative tells you. So we see 90 here, negative 90. 120 is bigger than 90, but it's smaller than 180. So we know we're going to terminate in this quadrant right here, and we're going to go this direction going down since it's negative, so that's negative 120 degrees. That's in standard position. Let's try another one. Let's do number 3 is 150 degrees. So I'd like you guys to take a minute here and try to sketch that in standard position on that set of axes. All right, so hopefully you said your vertex is at the origin, your initial side's on the positive x-axis, and then to get to 150, we're going to be less than 180, so we're going to be over here, open 150 degrees with your arrow. The other thing I said to do, and I haven't on the last couple, is state what quadrant it terminates. So this would be quadrant 2. We'll go up real quick to these other two. This one should have been quadrant 1, and number 2, that one's going to be quadrant 3 that it terminates in. All right, and let's do one more. I'll put it over here. Number 4 is 480 degrees. We want to graph that in standard position. So 480 is bigger than even 360 degrees. So we know 360 degrees is a full circle. So first let's start with our origin is our vertex, initial side is the positive x-axis. Those don't change. Now I need 480. Well, I know if I do a full circle that's 360 degrees. So how much more than 360 degrees is it? So let's take 480 and subtract 360 degrees from that. And that gives us 120. So we know we're going a full 360 degrees. So to show that, you do a full, it's almost like a little swirl. So you start at your initial side, you're going a full 360 degrees, and then an additional 120. So remember, this is 90 and 180. So now we're going to go 120 degrees. And that's how you would graph that angle. So you're going a full 360 degrees and then an additional 120 for a total of 480 degrees. So those are how you would graph an angle in standard position. So that's something basic that's really, really important as we move on with all of this trig stuff. All right, next we're going to talk about coterminal angles before we move on to our reference angles. So coterminal angles. Think about what coterminal means. Co means together, cooperate. And terminal means ends. So coterminal angles, what that means is angles that start and end in the same spot. So really, all you're doing here is you're finding multiples, you're adding and subtracting multiples of 360. So you're adding on circles or subtracting full circles. Take a look back at number 4 real quick. So this angle right here was 480 degrees. I also, if I were to graph the angle of just 120 degrees, let's see, if I graphed 120, I don't know if that color is different enough, it would still start here and it would end here. From here to here is 120 degrees. So if I didn't draw this little swirl here, you wouldn't be able to tell which angle it is. Is it 480 or is it 120? They both start here and they both end here. Those are called coterminal angles, 120 and 480. I also could have gone around two 360s and then an additional 120. I also could have gone this direction and in the negative direction. And we'll talk about how to figure out what those angles are. So we have an infinite number of angles that start and end in the same spots. Okay, so for the next ones, I want to find a positive and negative coterminal angle. So this is number 5. So given, we'll start with 45 degrees again. So given 45 degrees, I want to find an angle that starts in the same spot and ends in the same spot. So here I know 45 degrees, we drew it before. Vertex is the origin. Here's a 45-degree angle, terminates in quadrant 1. So I could also take, and you always want to start with the angle. Always start with the given angle. So you don't want to do 360 plus, 360 minus. Obviously, plus will still work, but I want you to get in the habit of doing the angle first. So I could take 45 degrees and add 360 degrees to it. So that gives us 405 degrees. So if I were to graph 405 degrees, let's see, I can get that green in there. 405 degrees means I would still start right here on my initial side. I'd go a full 360 degrees and then an additional 45. So they still start and end in the same spot, but there's two different angles. Here's 450 degrees. This one's 45 degrees. Now I also wanted a negative coterminal angle. So I can take my angle and subtract 360 degrees from it. So if I do 45 minus 360, that gives me negative 315 degrees. So what that looks like, negative angles always start by going down. So I would go down, negative 90, negative 180, negative 270, negative 315 degrees. I don't know why the mouse keeps going there. So that is another coterminal angle. It still starts and ends in the same spot, but it's a different degree measure. And we could continue finding more. We could add another 360 onto 405. We could subtract 360 again from negative 315. So you can find multiple angles there. Let's try another one, 535 degrees. So take a moment, pause the video, and find a positive and a negative coterminal angle there. All right, so again, always start with your angles. So if I do 535, I'm going to start with subtracting 360. So that gives me 175. So I've found a positive coterminal angle. I found it by subtracting, but it's still positive. So now I need to still find a negative one. So I'm going to take 175 and subtract another 360 from that. And that gives me negative 185. So now I found a positive and a negative coterminal angle. If you had started by doing 535 plus 360, that would also work. So 895 would be another coterminal angle. The idea here is you can continue to add and subtract 360 as many times as you'd like. You're going to end up with all coterminal angles, and there is an infinite number of them. Sometimes they put this on multiple choice, and you need to figure out how you have to just keep adding or subtracting 360 until you get to one of their choices. Actually, we're before 7. We're going to now move on to talking about reference angles. So this is something really important that you will have to use for a lot of the trig stuff we're going to be doing, and you'll also be using it a lot next year in pre-calc as well. So reference angles. 3 things you need to know about reference angles. 1, they must be positive. 2, they must be acute. And 3 I just say because of common mistakes that happen, they must be formed with the x-axis, not the y-axis. Okay, really important that you know these 3 things. Have that memorized about reference angles. They must be positive, they must be acute, and they must be formed with the x-axis. So it's a little bit different of how we're going to find a reference angle depending on what quadrant it's in. So if you are in the first quadrant, 1, quadrant 2, quadrant 3, and quadrant 4. So if you're in quadrant 1, then that angle would be positive, acute, and formed with the x-axis. So that would just be itself. So in quadrant 1, the angle is whatever your reference angle is. It's the same. If you're in quadrant 2, then, so if your initial angle starts here and goes to here, your reference angle is always formed with the x-axis that's closest to it. So I always say darken your, or squiggle out if you don't have another color, your terminal side, and then find the part of the x-axis closest to that squiggle. So is the positive side closer or the negative? In this case, the negative. So to find that angle, that yellow angle is your reference angle. So to find that angle, you would take 180 minus your reference angle. So if we went a full 180 is right here, but we don't want to go quite 180. We want to go this yellow amount less than 180. So we take whatever this angle is right here and subtract that from 180. If you're in quadrant 3, you're going to do your reference, take your angle and subtract your, subtract 180 degrees from that. Sorry, I put reference angle here. I should have just written angle. We're going to talk about going both directions. So here, not all today, but right now we're just talking about reference angle. So this would be 180 degrees minus whatever this full angle is here. It will leave you with the yellow angle. So that's what you would do in quadrant 2. For quadrant 3, you would take whatever your angle is and subtract 180 degrees from that. And in quadrant 4, you're going to do 360 degrees minus your angle. So some students like to just memorize those rules. Most students, though, like to just figure it out as they go. So let's take a look and do some of these to see what I mean to figure it out as you go. So now we're on number 7. So all of the next problems, we're going to find the reference angles of each. So the first one is 60 degrees. So when you're finding a reference angle, the first thing you should do is graph it. So we have our set of axes, and then initial side is positive x-axis. 60 degrees is going to be in quadrant 1. So when we find the reference angle, we're going to squiggle the terminal side or darken that side, and then find the part of the x-axis that's closest to that. So is it the positive x-axis or the negative? In this case, the yellow is closer to the positive x-axis. So that yellow angle is my reference angle. Well, that's also the original angle that I was given. So my reference angle is positive, 60 is positive, it's acute, 60 is acute, and it's formed with that x-axis. So the reference angle is 60 degrees. Nothing changes. It should be really quick to find your reference angle when you're given a positive acute angle because there's nothing you need to do. That's the answer, is 60 degrees. Okay, so, and let's write out our steps as we do these two. So 1, highlight or darken the terminal side. And then number 2, highlight or darken the part of the x-axis closest to the terminal side. And that is your reference angle. Okay, so again, I say x-axis because you're never, ever going to use the y-axis. You're always going to highlight or darken or squiggle out the x-axis. All right, the next one I want you to find the reference for or angle for is 240 degrees. So first, I want everybody to pause your video and sketch a 240 degree angle. Squiggle or highlight the terminal side in the part of the x-axis, and then see if you can figure out what that angle would be. All right, so here I'm going to first draw my vertex and my initial side. I know this is 90, 180, and 270. So 240 is a little bit less than 270, so we know that's going to terminate in quadrant 3. So this is my original angle of 240 degrees right there. So let me change colors. I'm going to highlight or darken my terminal side or squiggle it out, and then squiggle out the part of the x-axis closest to it. So in this case, we're closer to the negative side of the x-axis, so we squiggle that. So this right here, that's your reference angle. So we want to find the measure of that. Now I know the measure of this entire angle is 240 degrees, but I don't want the full angle. I want just this red part. So if I know the entire angle is 240, and I know that from here to here is 180 degrees, I can take 240, subtract my 180, and that should leave me with just this red part of the black angle. So that gives me 60 degrees. So my reference angle, again, is 60 degrees. All right, let's try another one. This is number 9. So 120 degrees. Pause the video, see if you can do this one on your own. Okay, so first you should have started by graphing your angle. So 120 is going to be in quadrant 2. And then we take a different color here, and I'm going to darken the terminal side and the part of the x-axis that's closest to it, which is the negative side. So this right here, that's the reference angle. It's got to be acute, it's got to be positive, and formed with the x-axis, not the y-axis, always the x. So how do I find what that blue angle is? Well, I know that the black angle is 120, and I know from here to here is 180 degrees. I only want the blue part. So how could I find it? Well, I can take 180 degrees, which is this whole straight line right here, subtract the black angle from that, and that would leave me with the blue angle. The blue angle plus the black angle add up to that full straight line red angle of 180 degrees. And again, that's a 60-degree reference angle. Okay, that was our last 60-degree one. All right, let's try 315 degrees. Sketch your angle, see if you can figure out your reference angle there. Again, you're going to graph this out. So our vertex here, initial side, positive x-axis. This time we've got 90, 180, 270, and 360. So that tells us that we're going to terminate in quadrant 4. So from here to here is 315 degrees. Change colors, squiggle your terminal side of your angle, and then also the side of the x-axis that's closest to that. So decide, is the positive side closer or the negative? And here, the positive side is going to be closer. It's always going to be, so for quadrant 1 and 4, you're going to do the positive side, and for quadrant 2 and 3, you're going to do the negative side. So this angle right here is your reference angle. Again, it has to be positive. It has to be acute and formed with the x-axis. So how do we find it now? Well, we know that from here to here, full circle is 360 degrees. I know this red angle here is 315 degrees. So how much extra do we have after that 315 degrees to get to 360? How can we find that? We can take 360 minus our 315, which gives us 45 degrees. So this angle right here is 45 degrees, which is my reference angle. All right, let's try another one. So number 11. 11 is negative 45. Okay, so for a negative angle, pause the video and sketch out a negative 45 degree angle in standard position. So remember, negative angles are going to start by going down. So still have our vertex, our initial side, but since it's negative, negative tells us the direction, it's going to go down. So this is negative 90, so we're going to be in quadrant 1. So that's negative 45 degrees. All right, now squiggle your terminal side, squiggle the part of the x-axis closest to that, and we just trace the exact same angle. So is negative 45 degrees acute? Yes, it's less than 90. Is it positive? No, it's negative. But we know that this angle is 45 degrees. It's just in the negative direction. So your reference angle is just going to be 45 degrees. You just take off the negative. If it's acute and negative, then we just take off the negative and you have your reference angle. Again, negative just tells you the direction. All right, the next one is negative 210 degrees, and this will be our last reference angle one for the notes. Pause your video. I want you to sketch it and see if you can figure it out. I know it's a little bit different, but don't worry about so much that negative. Only think of the negative as telling you the direction. Okay, so give that a try. Okay, so first you should have graphed it. Now, when we graph it, we are thinking negative. We still start, though, at the initial side as the positive x-axis. Since we're going down, this is going to be negative 90, negative 180, and negative 270. All right, so we're at negative 210, which puts us in quadrant 2. So from here to here is negative 210 degrees. So how can I find my reference angle? Well, let's do the same system that we've been doing. So darken or squiggle your terminal side and the part of the x-axis closest to that. So in this case, it's our negative x-axis. Always the x-axis, though, never, ever the y. So this angle right here is my reference angle. How do I find it? Well, I know from here to here is 180 degrees in the negative direction, but it's still 180 degrees. I know from here to here is 210. So how can I find just this squiggle part there, just the reference angle? Hopefully you're thinking that if you take that full red angle of 210, ignore the negative because that's just telling our direction, and subtract 180, again ignoring the negative because that's just direction. If I take 210 minus 180, that gives me 30 degrees. So this angle right here must be 30. So 30 plus 210 would give me, 210 is the entire angle here. If we do 210 minus 30, that would give me 180. Or 30 degrees plus 180 would give me 210 degrees. Okay, so you're always trying to use that 180 to find it. If it's in quadrant 2 or 3, you're using 180 there. If you're in quadrant 1, the angle is going to be whatever it says it is. And if you're in quadrant 4, then you're usually going to be using 360, or like in number 11, you're just taking off that negative right there. All right. Next, we're going to talk about converting. So up until now, you guys have mainly just used degree measure. You may have seen a little bit of radians last year in geometry, but I'm guessing you guys probably did not. So radian measure it's like when you are doing temperature. You can measure the temperature in Fahrenheit or Celsius. So it's two different ways of measuring the same thing. Same idea with angles. We have degrees that we can measure an angle with, but we also have radians. And we can convert between the two. So we know that in 180 degrees, that's equal to pi radians. So to convert between the two, whichever direction you're going, whether it's degrees to radians or radians to degrees, you want to use this proportion. So pi radians we know is equal to 180. So we put pi over 180 equals the number of radians you have over degrees. So a really important proportion to know here. Pi over 180 equals radians over degrees. Also really important to remember that 180 is equal to pi. That's why this proportion works. We're setting it to something we know that's equal. All right, so first let's go from radians to degrees. So we're on number 13. So convert pi over 4 radians. And radians doesn't have a symbol like degrees has that little circle. We don't have that for radians. So convert pi over 4 radians to degrees. So we have a nice quick trick that we can use if we are given a pi when we're in radians. So if given pi in radians and you want to convert to degrees, all we have to do is remember that pi radians is equal to 180 degrees. So all you have to do is sub in 180 degrees for pi. So that's kind of like our quick trick here. It won't always work if there's no pi in there, but if there is a pi, then that's what we can do. So I can take now 180 degrees, put it in for pi, and divide that by 4. So 180 divided by 4 gives me 45 degrees. So that is equal to pi over 4. Now, if you wanted to set up a proportion and do pi over 180 equals pi over 4 over x, that's fine too. It's just a little bit harder to do. This way is a little bit quicker. So if you're ever stuck, I'll show you that way as well. So if you forgot that you could sub in, you could always do pi over 180 equals pi over 4. And we could call the degrees x here, so setting up our proportion. And then you could cross multiply. So here's where it does get a little tricky, because you have pi x equals pi over 4 times 180. And then you could reduce this 180 over 4, and then your pi's would cancel out, leaving you with x equals 45. But again, that's a much harder way to do that if you're given a pi. So this time convert 3.5 radians to degrees. So this time we don't have a pi, so we can't just sub in 180 degrees. So this time we have to use our proportion. So there's no pi, so use the proportion. So our proportion says pi over 180, because we know they're equal to each other, equals radians over degrees. So I know that the radians is always across from the pi. So if you did happen to flip it to be 180 over pi, then radians would go on the bottom. But here pi is on the top, so radians goes across from that. And we're solving for the number of degrees, so we'll call that x. So now we're just going to cross multiply here. So we have pi times x equals 630. To solve for x, we divide both sides by pi. So this is in degrees now, so x is equal to 630 over pi degrees. So here's, you wouldn't want to sub in 180 in for pi here, and this is where it can get a little confusing because this is already in degrees. The subbing in 180 in for pi is only used when you're converting from radians to degrees. Once you're in degrees, now if you wanted to get a decimal for this, you would go to your calculator and type in 630 divided by the pi key. So let me grab this calculator real quick here. I don't think it's opening. Oh, there it is. So here you would take 630 divided by pi and enter. I don't know if it's hard for you guys to see this too, or if it's just the board, but then we would get 200.5352283, and that would be the approximation. So this right here is exact, and then the approximation, you could write out your entire decimal, would be 200.5352283 degrees. And that is an approximation. Okay, now let's go the other direction. So now let's go from degrees to radians. So we use that same proportion to go either direction, unless you're given a pi in radians and you're converting it to degrees, then you can just sub in your 180 in for pi. So convert to degrees, from degrees to radians. So convert 90 degrees to radians. Okay, so to do this, we use our same proportion. So pi over 180 equals radians over degrees. So this time I don't know the radians, so I'm going to call that x, and 90 goes across from 180 because those are degrees, and then you're going to cross multiply. So we get 180x equals 90 pi. We're solving for x, so we're going to divide both sides by 180. Now here we want to leave our answer in terms of pi, and that's really important. So in your calculator, and you can use the alpha y equals button, just type in 90 over 180, and you might be able to do this in your head too, but you want to be able to reduce that in your calculator. So do 90 over 180 and reduce that. So you could do alpha y equals, and you'd have 90 over 180, and that you can see reduces to 1/2. So here we could write this as 1/2 pi or pi over 2. We don't have to write the 1, so we usually write that as pi over 2. So 90 degrees is equal to pi over 2, and that's one we're going to eventually want to have memorized. We'll talk next class about our unit circle, and that will be 1. So again, this part you're going to reduce, and you can use your calc to do that, or that one you could have done in your head. All right, next one, convert 30 degrees from degrees to radians. Pause your video here and try to convert that using your proportion on your own and give the answer in a reduced fraction form in terms of pi. So here we'd have pi over 180 equals, we're looking for radians, so that's x over 30, cross multiply. We get 30 pi equals 180x. Divide both sides by 180. And again, reduce the 30 over 180. And you can do that right in your calculator, which you already should have done, should give you 1 over 6. So that would just be pi over 6 would equal your x. All right, and let's do one more of these. Convert 135 degrees to radians. Pause your video, go ahead and convert 135 degrees to radians. All right, so I will look for your work on this one, but you should have a final answer of 3 pi over 4, doing it that same way that you did it in the last couple problems where you set up your proportion. You would put in 135 in for the degrees, and then cross multiply and reduce your fraction. All right, so a lot of really, really important concepts that we talked about today. Make sure you can graph your angle in standard position. Make sure that you can, that you understand how to find the reference angle and coterminal angles, and also be able to convert between radians and degrees. All really important things that will be coming up for the rest of this unit. So if you do have any questions, of course, come and see me or send me an email or let me know. And other than that, I hope you guys have a great day. Bye.